Now, what we've done, we've installed Packet Tracer and then we've placed our first devices. And then now we're going to open, we're going to watch the packets travel through the OSI model, live layer by layer. But before we touch the software, let's just quickly do a review. Let me do a quick review. The two models that you must know: the OSI model, the TCP/IP model. The OSI model has 7 layers. All right, it has 7 layers from top to bottom, which is application, presentation, session, transport, network, data link, and physical. Now, the TCP/IP model is the real world version, because it actually, in a real world version, it actually collapsed the OSI model 7 layers into 4, right? Which layers 1 and 2, and then internet, which covers OSI 3, and then there's transport, same as OSI, and then application, which covers OSI models 5, 6, and 7. Now, let's talk about building the topology, right? Let's get into the packet tracer. So we have this file here that we've created. So we're going to build a simple but powerful topology. So we need 3 PCs, 1 switch, and then 1 router. So this will let us see the traffic just moving across a different network. Now let's go ahead and click on the end devices. I think it's this one, the second one, and then we need 3 pieces. So I don't know if I can move this a little bit up here. I think I can, and then I'm gonna just put 1, 2, 3. All right, so same goes, we have to rename this. Again, you double click, go to config, so instead of being PC 0, so this is gonna be PC Johannesburg 01. Okay, and then we can just close this, and then this one, double click, config. So this can be a PC Johannesburg 02. All right, let's just put these ones somewhere here, and then this one I'm gonna just put here because this one is gonna be Cape Town. So I'm gonna double click, let's config, and then this one is gonna be a PC CPT 01. Let's close this. All right, so now the first 2 are in Johannesburg, and then the third is in Cape Town. Now we already have a switch. I think we already have a switch which is SW Johannesburg. Oh, we don't have Johannesburg switch, isn't it? So we need to add a new switch. So let's go to the network devices, and then we're gonna go switches, and then let's add 29 switch. I'm gonna just put him here, and again we need to rename this. I thought we already had like a switch. So this will be we call it what, SW Johannesburg 01. just save and let's close this one. Okay, so let's do like this. And then now what we're gonna do, we're gonna connect PC1, Johannesburg PC1 and Johannesburg PC2 to the switch using a copper straight through cable. So for PC1 we're gonna use a fast Ethernet 0. So we're gonna go to the connections. Just wanna close here. So there's a copper straight through. So we're gonna use fast Ethernet 0, and then here we summary use fast Ethernet 01. Now, I mean, for the PC side, you always select fast Ethernet 0. So this is a simulation of your Ethernet card or your NIC card. And for the switch side, you can select fast Ethernet 01, 02, 03, 04, 05, and so on, respectively, depending on, of course, on the devices that you've got. You can see now that the switch port have learned the two PCs depicted by the green rectangles. Now, so we already have that 2901 router, which is RTR Johannesburg 01. So we need to connect our Johannesburg switch to gigabit Ethernet 0/0 using the straight through cable. So we'll just connect this switch, which is gigabit Ethernet /01, to this one. Okay, so this router is missing, it doesn't have all the ports, so I'm just gonna go and delete the Cape Town connection. Actually, I'm gonna delete both of the connection. We'll deal with those later on. Where's the delete thing? So we can also delete that. So let's delete that connection. We'll just deal with that a little bit later on. All right, now we can go ahead and connect our switch gigabit Ethernet 01 to gigabit Ethernet 00. And then we're gonna connect the Cape Town PC directly to the router using a straight through as well. So we can do the same thing here. The Cape Town PC to the no, not to the switch, to the router. Sorry, my bad. I wanted to actually do to the PC. To the router. So I'm just connecting the Cape Town PC directly to the router. Let's give everything IP address, because right now they cannot communicate. So let's give everything an IP address. So you need to open the properties. You can click on the desktop tab. So let's start with PC Johannesburg 1. So you can click on it, and then under config, let me just bring this. We can give it an IP address. Sorry, you're gonna click on desktop, and then you're gonna click on IP configuration. So you click on desktop and IP configuration, and then so it's static, and then we're gonna give it an IP of 192.168.1.10. So this 192.168.1.10, and then the subnet mask there's 255.255.255. The default gateway, let's make it 192.168.1.1. So that will be our router interface, that 1.1. And then you can just close it or click OK, or we can close it. Right, and then let's just make sure. Yeah, so you can actually see now that it's set by hovering over it. And then we can do the same thing with the PC2. So this one we're going to give a static IP of 20. So again, you go to desktop and then IP configuration. So this one is going to be a 192.168.1.20, and then the gateway is 168.1.1. So we don't have to put the DNS for now. So it's the same gateway. So all the PCs, they are using the same gateway. All right. Now the Cape Town is going to be a little bit different. So the Cape Town PC is going to be a little bit different. So this one is a different network. So the Cape Town side, the IP address, we can just make it. Let's go ahead and desktop and then IP. So the Cape Town will be, let's make it 192.168.2.10, and then the subnet mask is still gonna be that, but the default gateway is gonna be 192.168.2.1. So it's a little bit different. And then we're gonna just go ahead and close that. All right, so our PCs, I think they are set. You can see the IP address is 192.168.2.10, and then the gateway there is 192.168.2.1. So these ones is .1.10 and then .1.20, and then the gateway is .1.1. All right, so we've set this. Now let's configure the router. We need to configure the router. So you're gonna click on the Johannesburg router. So let's click on it, and then here you will click on CLI. So CLI means command line interface. I think we must just enable enable first, like this, and then you'll see you're gonna have a router with like a hashtag. So we enable, and then you have a router hashtag, you see that? And then we're gonna say configure terminal, configure all right, so let's run terminal first. Yeah, then you're gonna get into, sometimes it doesn't allow you to actually type a long thing. So the first thing is enable, and then configure terminal, and then you will get into interface gigabit Ethernet 0/0. Then you're gonna be in the interface command line. You can just say IP address. So we can give it IP address, like this IP address, which is 192.168.1.1. So we are giving that. Okay, I've got something wrong here. 192.168.1.1. So we're giving our gigabit port an IP address, or we're giving our router an IP address of 192.168.1.1, and then then it's going to be 255.255.255.0, which is our thingamajig, which is our subnet. Okay, and then we can say no shutdown. No shutdown. And then it will say the line. So basically the no shutdown is just change the port to be up. It changed the that state to be up. So it was offline, now it's online. All right, this is what it does. And then I'm just gonna say enter, and then I'm gonna exit this interface by doing exit here, and then we are back in router config again. All right, now we need to configure the second interface now. So here we're gonna say interface gigabit Ethernet 0/1, and then we are in that interface. Then we'll give it an IP address of 192.168.2.1, and then with a subnet mask of 255.255.0. And then again we will say no shutdown. And then exit. Now let me explain what we've done here. What we just tapped as enable put us into a privilege mode, right? So like the administrator mode, and then configure terminal opens the configuration mode. Then we entered each interface, we assigned IP addresses, and then type no shutdown, because by default the router interfaces are administratively shut down. So no shutdown just turns them on. That's all it does. So their router interfaces are shut down by default. So it must be manually enabled with no shutdown, and then switch ports are up by default. So this is a very common scenario that you might meet. Now the exciting part, in the bottom right of the packet tracer, you'll see we can actually exit this again. I was saying the exciting part is in the bottom right of the packet tracer. You'll see two buttons: the real-time simulation. You see those buttons. So let's click on simulation. And then we've got that open, that the panel that opens up. Now the simulation panel just opens on the right. Now we can filter what traffic we want to see. So you can click on edit filters. So I'm gonna go ahead and edit filters, and then we wanna make sure that ICMP, I think, is already checked. So you want to make sure that ICMP is ticked. So I think it's already ticked. So it's already ticked. So we don't have to do anything. All right. Because now we can filter what the traffic we want to see. ICMP is a protocol that is used by for ping, by ping command. Now let's send a ping. So I'm gonna go ahead and close this simulation panel, and then I'm gonna click on the Johannesburg PC 01, and then I'm gonna ping this PC here that is in Cape Town. All right, so let's go ahead and do that. So that's gonna open. Then we're gonna go to terminal. CMD command prompt terminal. Oh, we can use a CMD or command prompt, doesn't matter. And then we will just ping ping 192.168.2.10, which is the PC that is in Cape Town. Now, but minimize this one, don't press enter yet. Alright, so just minimize it. And then let me just get my simulation window. A parsing envelope appear on Johannesburg office. You see that envelope? Look at that. There is that parsing envelope that's appearing in the Johannesburg office. Sorry guys, I just don't have a bigger screen to show you like things that are happening in the background, but I'm just trying my best here. So that means that now the ICMP packet is actually waiting to be sent. So we can just click on the play button to send it. You see that? You see it now in real time. So there is something wrong with the PC2. So you can watch the packet moves from PC1 to the switch, and then you see now it finally moved into Cape Town. So it actually moved from Johannesburg to the switch, right? And then you can click on that envelope to open. You can actually click on the envelope to open the PDU, or it opens the protocol data unit information window. All right, so let's actually click on that envelope to let's just click on that envelope. So it opens this PDU information. Okay. I wanna make this bigger. Sorry guys, I've got so many windows now. And then look into the information that we are having here. Look at the information. Layer is layer 2, right? Layer 1, layer 1, layer 2, layer 3, layer 4, layer 5. This is the OSI model. So you can look at the OSI model right here. You can see every layer being processed. At the bottom, layer 1 is the physical, the bits that are being transmitted as the electrical signal on the cable, and then layer 2 is a data link, right? And then the Ethernet frame is being built with a MAC address, and then layer 3, which is the network, the IP packet is being encapsulated with the source IP of 192.168.1.10. All right. Now watch the packet, how they arrive on the switch as well. So at the switch is probably only okay, now they are at the router. I'm just waiting for it to go to the switch. I'm just waiting for it to actually go to the switch. Okay, now they're at the switch. Now let's look at the switch. So on the switch, it's only, let's get the PDU information. I just want to resize it. Where did it go now? Oh, there we go. So on the switch, basically, it's only layer 1 and 2 that are processed. The switch reads the MAC address, and the switch just reads the MAC address and forwards it. So it doesn't look at the what do you call the IP. Now look at that. Let me just close the simulation window, and then you can actually see on the switch. You see the header has a MAC address. Now when the packet reaches the router, you must watch what happens there. The router process it will process layer 1, 2, and 3. It just strips off the old Ethernet frames. It reads the IP address of 192.168.2.10, and then it looks at its routing table. Then it builds a new Ethernet frame for the outgoing interface. So this is called routing, and this is what makes the router different from the switch. So I mean, think of let's make an analogy here. Think of maybe a South African post office. I know it's useless right now, but let's make an example. So the physical envelope, which is layer 2 frame, changes at each post office, like which is the router hop, right? But the letter inside the data stays the same. So each post office will do what? Post office is our router now, right? Yes. It will read the address, which is the layer 3 IP, and then creates a new envelope for the next leg of journey. Okay, so you can continue stepping and watching the packet reach PC1 that is in Cape Town. Then an ICMP reply comes back the same way. You can actually see comes back. So this round trip is what you see as a ping successful in the command prompt. So normally when we just say ping Google what, this is what is happening in the background. You understand? So that's the OSI model in action. This is not just a textbook, but it's live in front of our eyes, right? So, okay, so I mean, there's just live packets travel through the OSI model in real time. So you saw layer 1 transmitting bits, layer 2 handling MAC addresses at the switch, and then layer 3 IP routing at the router, and then ICMP at the application layer. So now tomorrow what we're gonna do, we're gonna master IP addressing and subnetting, right? And then we're going to implement a real addressing scheme, you know, for our LPDA solutions enterprise network across the 3 South African cities. You can see we still have the Cape Town switch and the Durban switch that are not connected. All right, so we will do that. And then you will see that OSI model now will finally make a little bit of a sense.